The term IMU typically refers to an inertial measurement unit, a critical component in modern navigation systems that calculates an object's position, orientation, and velocity by sensing its motion using a combination of accelerometers and gyroscopes. However, in the context of ancient weaponry, the relationship between IMUs and age-old armaments, though seemingly disparate, offers intriguing insights into the technological evolution from rudimentary tools of war to sophisticated systems utilized today. IMUs represent a bridge from the past to the future, illustrating humanity's consistent quest for precision and effectiveness in warfare. Although ancient weapons, such as catapults or ballistae, may not have incorporated electronic components, their designs demanded a comparable understanding of physics, trajectory, and mechanics, principles that IMUs now enhance in modern contexts. One interesting example is the trebuchet, a type of catapult that utilized precise counterweights to launch projectiles. The same foundational physics that ensured accuracy in projectile motion centuries ago underpins the algorithms used in IMUs, which account for gravitational forces and angular velocity. The computational evolution from counterweights and ropes to microprocessors and sensors not only reflects technological advancements, but also highlights a continuous narrative of adaptation and innovation. Another example is the use of personal firearms in both historical and modern frameworks. Advanced armaments today integrate IMUs to improve targeting accuracy. A notable application lies in smart firearms that use IMUs to ensure precise firing solutions, adjusting for environmental variables to achieve unparalleled accuracy. In this sense, the legacy of improvement illustrated by ancient tools continues to influence modern warfare technologies. Opinions supporting this idea often regard the seamless melding of past and present engineering as a testament to human ingenuity. Technological evolution is championed as a crucial factor in maintaining tactical superiority. However, challenges arise from ethical considerations surrounding the militarization of advanced technologies, potentially escalating conflicts rather than deterring them. Moreover, some detractors may argue that the romanticization of ancient weaponry's influence on modern systems overlooks historical contexts and the tragedies of war, drawing attention to the darker facets of technological advancement. Despite these controversies, the deep-rooted connection between the physics of ancient weaponry and the functionality of modern IMUs offers valuable insights into the continuum of human innovation. This point underscores the broader narrative of how principles developed in ancient times continue to impact current and future technological landscapes, influencing everything from military strategies to daily navigation tools. Thus, understanding this link enriches our comprehension of both historical and modern technological paradigms. To delve into the historical background of understanding IMU technology, it's crucial first to define what IMU, or inertial measurement unit, truly embodies. An IMU is an electronic device that measures and reports a body's specific force, angular rate, and sometimes the magnetic field surrounding the body using a combination of accelerometers, gyroscopes, and sometimes magnetometers. This sophisticated technology serves as a core component in navigation systems across various platforms, including aviation, marine, and automotive industries. IMU technology holds significant importance when exploring its interconnection with ancient weapons. Primarily, it sheds light on how modern advancements provide insights into the design principles and operational mechanics of historical armaments. Importantly, IMU technology aligns with the ancient area's constant struggle to enhance stabilization and accuracy, akin to how one might steady a bow or balance a trebuchet's counterweight. In terms of real-world applications, one notable example is the use of IMUs in modern projectile launchers and guided missiles. They provide critical data that ensures precision targeting, echoing the efforts of ancient weapon makers who strove for accuracy with rudimentary means. Another application is in archaeology, where IMUs facilitate a deeper understanding of ancient battlefield dynamics by reenacting and simulating weapon trajectories and impacts. This can unearth valuable data about how battles unfolded and offer new perspectives on historical encounters. Supporters of this idea argue that the line between ancient and modern technology is thinner than presumed. They view this continuum as an ongoing quest for improved efficiency and accuracy, which ancient innovators initially laid the groundwork for. However, some critics contest that drawing parallels between ancient mechanical ingenuity and modern electronic systems may oversimplify historical contexts or technical complexities. They argue that technological leaps over centuries ought not be conflated with continuous evolution, but rather viewed as disparate jumps in human cognition and capability. Potential challenges with this perspective involve balancing historical appreciation with technological idealization, where ancient achievements are not overshadowed by their modern iterations, but celebrated for their era-specific ingenuity. Despite these controversies, understanding IMUs within this historical framework influences how we perceive technological advancements as part of a broader timeline, where each innovation harkens back to fundamental human challenges and triumphs. Ultimately, this connection enriches our appreciation of technology, blending past insights with present advancements, highlighting the enduring legacy of exploration and innovation. The concept of evolution of ancient weapons and tactics refers to the historical progression and refinement of technology and strategies used in warfare throughout ancient times. This evolution was driven by the constant need for communities to defend themselves and expand their territories, resulting in the development of increasingly sophisticated weapons and military tactics. The significance of this point in relation to the main topic, the connection between IMU and ancient weapons, Unraveled, lies in understanding how advancements in weaponry and tactics impacted the relationship and influence between IMU, a concept potentially representing interconnected forces or entities, and ancient combat methods. Analyzing this evolution provides insights into how ancient cultures adapted their tools and strategies in response to encounters with diverse adversaries and changing environments, potentially guided by unseen influences or strategic insights. For tangible examples, one might consider the progression from simple stone tools to complex bronze and iron weaponry. The shift from stone to metals allowed for more durable and effective weapons such as swords, spears, and arrows, changing the nature of warfare itself. In terms of tactics, the development of the phalanx formation by the Greeks is notable. This tightly knit military formation utilized long spears and shields, enabling soldiers to move as a unified force, illustrating a tactical evolution that significantly altered battle dynamics. Opinions supporting the evolution of ancient weapons and tactics suggest that these advancements were crucial for the survival and success of civilizations. The constant arms race pushed innovation and strategic thinking, contributing to significant achievements and shifts in power. However, This evolution is not without its controversies. Some argue that the relentless focus on weaponry may have stunted certain aspects of cultural development, as resources were often prioritized for military purposes over other societal needs. Challenges in analyzing the evolution of ancient weaponry include the limited archaeological evidence available and the difficulty in accurately interpreting ancient texts or artifacts. These challenges sometimes result in differing viewpoints on the impact and significance of certain weaponry or tactics. This evolution connects to the main topic by illustrating the broader narrative of how ancient societies, potentially under the influence or guidance of Emu, adapted and refined their combat methodologies to enhance their power and survival. It highlights the interplay between technological advancement and strategic innovation within ancient cultures, shaping their development and interactions. Understanding these connections allows us to appreciate the complexity of ancient warfare and its lasting influence on human history. The concept of connecting the dots, initial theories and research, delves into the foundational aspects of exploring the link between Emu, a term that can suggest various interpretations across different cultures, often associated with an ancient cultural or technological relevance, and ancient weapons. This segment aims to establish a theoretical and investigative framework that can lead to distinct conclusions about how these seemingly disparate elements might be intertwined. By setting a base with theories and research, it highlights the importance of a structured approach to historical inquiry. The significance of connecting initial theories and research to this overarching topic lies in its capacity to provide a structured pathway to explore how ancient knowledge systems, symbolized here by Emu, might have influenced or even directly contributed to the development of ancient weaponry. Understanding these connections can offer profound insights into the technological advancements of ancient civilizations and their cultural exchanges, which are critical to comprehending the evolution of martial technologies. One pertinent example is the study of Polynesian navigation systems, where the term Aimu might relate to traditional knowledge and technologies. By examining such systems, scholars can postulate theories on how sophisticated forms of navigation could parallel or influence military strategies and weapon design in ancient times. Similarly, some studies investigate the metallurgy used in ancient Pacific Island weaponry, suggesting cultural exchanges and shared technologies that might be attributed to knowledge coded within the concept of Emu. Scholars and historians have voiced their support for interdisciplinary studies that connect cultural knowledge with technological developments. They argue that many ancient societies had advanced forms of knowledge that encapsulated both civil and martial applications, believing that studying these aspects together can shed light on how ancient peoples viewed and interacted with their world. Despite the potential insights offered by this approach, there are challenges and controversies. Critics argue that drawing direct connections can sometimes result in speculative history, where assumed correlations are mistaken for causations without substantial evidence. Furthermore, there's a risk of oversimplifying or misrepresenting cultural terms like Emu, by placing them within a strictly militaristic context, thereby eroding their broader cultural meanings and significance. Ultimately, the exploration of initial theories and research into the connection between Emu and ancient weapons serves as a critical building block that influences subsequent investigative paths within the topic. It catalyzes further exploration into interdisciplinary fields, encourages comprehensive analysis of historical contexts, and seeks to advance understanding of how cultural knowledge impacted the technological capabilities of ancient civilizations.